So this is year number 12 of a project that we started to conserve Arctic grayling in the Upper Pembina region. So it was 12, 13, 14 years ago. I can remember us sitting in this hall downstairs in the basement here, and we were looking around, and we kind of Mirror Lake was kind of done, and there was some other work that we had done. We had some money in the coffers that was waiting to be spent, and Jim O'Neill was here. We talked about what kind of project could we possibly do. And we said, let's look at the Arctic grayling in the Upper Pembina region. At that time, Jim was a biologist that had done lots of work in the 80s, and he had some pretty good records of large numbers of fish in the Upper Pembina. And we knew from anecdotal evidence that a lot of these fish numbers had gone down. So what we wanted to do was kind of go out, survey the land, find out how many fish were left there, what kind of state the rivers were in, basically a habitat assessment that we thought would maybe take a couple or 3 years or whatever. We got onto a roll. We've done all kinds of really interesting work on that river. And believe it or not, we're into year number 12 on this project already. Just for some context, we did explore probably a dozen or more streams. We do have temperature probes in these streams, plus a whole bunch more a little bit further up. But the main areas that we found fish, and we've really been doing well, is Dismal Creek and Rat Creek. Those are directly west of Lodgepole. So this gives you a little bit of an idea of where those main areas are. We've got a couple of spots with a star on them. DC 10, that's our site. Dismal Creek 10 is at the Wolf Lake crossing. That was the site where in some of our early years we had a fish trap. So right after ice off, we went in, put a fish trap in, tried to catch as many fish as we could. It was kind of disappointing because we got a lot of ice flows, but we caught 0 fish. But that was the site of the fish trap. We were concerned because some people went exploring downstream and discovered a big log jam down at that one called DC08. And it is a massive, massive log jam. So we thought maybe that was part of the problem why we didn't catch any fish in the fish trap. DC3 was a location that we had a few years later. We had in order to prove that fish were getting through that big log jam, we went out, caught some fish, put a pit tag in them. So a pit tag is a little transmitter. It's about the size of a grain of rice. Your dog or your cat might have them. And basically we have a little device that you can scan, and you can run it over top of the fish or the cat. Emerson scanned his dog, and it'll show back the serial number of whatever that tag was. So we can tell that we've caught that fish before. DC03 was one of the locations that we put a big antenna right across the stream. So every time a fish swam through, we would know that that fish, there's a little computer attached to it. We knew that that fish had been swam by that location. And we were able to prove, we had another trap up on the other side of that fish, of that big log jam. We were able to prove that the fish were getting all the way through. So that wasn't an impediment to fish getting up into those higher reaches. So there was evidence of a lot of fish, and over the years we've looked at what are some of these of the causes of why there aren't as many fish anymore. And it's a cumulative effects problem, and there's a number of factors there. There's a lot of roads. There's forestry roads and oil and gas roads, and there's oil and gas activity, and there's injection wells in there. There's some places where the habitat is fragmented. There's a few little tiny tributaries that have hanging culverts, not too many in the main stem area. We do know that there's people in there that were fishing and keeping the grayling. Global warming, we know that those warm temperatures, and we'll get into temperatures a little bit later on, really have an impact on the survivability of Arctic grayling and where they like to be. So there's a whole bunch of things that went on. We worked with provincial biologists and said, all right, it was one of their first experiments with something called the Joe model, where they had a computer system and they put all these factors in and tried to figure out what are some of the things that we could do. So we talked to the forestry guys, and we were able to influence. Actually, one of the biologists was able to influence some of the forestry management plans, which was a big win. We knew that some of the sediment, their sediment was getting in at a number of places, and one of our big wins was we had an oil and gas company actually replace a bridge that was causing a lot of sedimentation issues. We know that the global warming is a problem. We can't really do a whole lot about that. One of the recommendations was to put in a 5-year closure on the river and try and let those grayling regenerate, give them a rest basically from angling. So the closure was started about 8 years ago, and it went on for the 5 years. There was some promising data that came out of it. We talked about that last year at our update, where the number of fish was increasing, the number of fish was getting a little bit bigger. They were really missing a data point. So one of the activities is that they go in and angle using at prescribed locations and compare that data year over year. And they had a bit of a trend line, but they wanted a little bit more data to extend that trend line out and make sure that what they were seeing really was an improvement in the grayling. So the stream is still closed again this year, and we'll get to it a little bit later on. But if everything goes well, we'll be able to accompany those biologists again in the fall, late summer, and we'll hit some of those locations again. Basically, we go out with the biologist. The area is closed, but they'll give us a license, and they will accompany us, and we'll go in. Some of them are a pretty good little hike into not they're not all right next to a road. Some of them you have to hike in. So, some of them are a long ways in, and it's not easy getting there, but some of the fishing was actually pretty rewarding. So we're hoping to be able to do that again. Major activities in 2022. So this is the report for last year. A little bit later on, I'll talk about what we're going to do this upcoming year. Last year, we had temperature monitors at 24 sites across the Upper Pembina. We did some aerial videography using a drone, a quadcopter. So at a number of locations, we went in and tried to just do a video inventory of what the banks looked like, what the stream flows were like, if there was pools, if there was issues. We tracked forestry issues with the drone a couple of times. So we did some additional work with the quadcopter again. We put trail cameras in at a few locations just to see, so that we'd be able to report back to the enforcement officers and say, hey, at this bridge crossing, we recorded a number of people that were angling in the area that's actually closed. And we actually did, we used some of those cameras and did some time-lapse photography on them and got some good ideas of what happens when there's a heavy rainfall. The water level comes up really quickly, comes down, what it does, what happens to the stream. This year we did something new, and it's called environmental DNA. So we did some environmental DNA work to basically confirm the presence of Arctic grayling or deny the presence of the Arctic grayling in a number of streams. So we'll talk about that in a little bit more detail. It was quite an interesting component of the project. And we also did some work on Rat Creek. So we went out and we used the drone, found some good spots, sent some folks out to some of those new spots and tried to catch some more fish on Rat Creek. That was the work plan for 2022. I'm going to take a breather here, a cup of water. Does anybody have any questions so far? Pace is good. Emerson?
I'm just curious about non-compliance. Any sign of that on your cameras?
Yeah, I'll show you a couple of pictures. Yeah, not a lot. So it's good news, but the statistics that we got, we'll get to it. There's some slides that talk about that a little bit more.
Any of that ground fed, any of the water, there's more Rat Creek.
When we talk about water temperature, Some of it is runoff, but some of the, like Dismal Creek in particular, is much colder than some of the other ones. So we don't know where they are, but we have some strong suspicion that it's underground springs that are feeding into Dismal Creek somewhere, because the water temperatures are significantly colder. Some of the other ones, Dismal Creek is actually quite a bit clearer than some of the others as well. So if we look at the Big Array or Rat Creek, we can tell by the tannin color that there's a lot of water that's just sort of oozing through the peat moss and so on, and it's picking up color and so on from the peat. But Dismal doesn't have that tannin color. It's when it's clear, it's almost clear.
And on that, I think it's referred to as the Joe model, where you listed the factors contributing. There were, I think, about 8 or 9 factors. 3 of them were fishing and fishermen related. And that's, from what I've heard, that's been some criticism of that model, that it's unfairly pointing the finger at fishermen.
So this was one of the first cracks at the Joe model, and it's evolved quite a bit since then. To tell you the truth, that was some work that we did several years ago, and I don't know what's happened with it lately. I know that they're still using the Joe model, but I'm not familiar with the criticisms or the drawbacks or the factoring. Like they can say, oh, oil and gas is, or the fragmentation is really a big issue here, so they can factor it up and down. I don't know if they still use the 3 different or multiple different angling type things or not. I don't know.
What's your sense of it?
I'm sorry?
What's your sense of it? Do you think that the fishermen are largely to blame for the drop in grading population up there or not?
It's definitely a factor. The numbers are low enough that an angler, if he was keeping fish, could go in there and fish out a pool or fish out a stretch in a weekend. There just aren't tons and tons of fish in some of these locations.
Are they using the model? They take data, say, well, here's some kind of cost, or are they using the model to say, we do something for this is how it is.
So the question is, how do they calibrate the model? How do they use the model? What I can do, there's a few questions on the models. I think what I'll do is invite one of the provincial biologists who's using the Joe model, or maybe even one of the developers of that Joe model, and say, tell us exactly how you're using it for bull trout, or how you're using it for maybe not the grayling, but how they're currently using it for the native Athabasca, or the Athabasca rainbows, or something like that. Does that sound like an interesting topic for the fall sometime? Okay. We'll talk about we'll get somebody to talk about the Joe model and how it's being used on some of the native trout recovery.
Where's that Rat Creek converted to?
Rat Creek is this one right here, coming down from the north this way. Dismal Creek runs parallel to in this section of it anyway, parallel to the Pembina, a little bit south. Yeah. So where do we get our money for this? Alberta Conservation Association has a grant program, and we were lucky enough to have our project fully funded, aside from the labor that we put in, because there's an awful lot of labor that goes into these projects. But they contributed almost $20,000. The biggest expenses were fuel, lab supplies. I'll talk about the eDNA project a little bit later on, but we purchased a pump that we could use. We had 2 crews out there doing eDNA work. One of them used a pump from the University of Alberta, and ACA bought one for this project as well. So we had a ton of support, or a ton of labor actually, from the members in our club. It was all volunteer time. And we had help from Environment and Parks. it's interesting. It's a really good relationship between us and the folks at Alberta Environment and Protected Areas. The biologists look to us for input on what kind of locations, what kind of projects, what kinds of initiatives we're interested in. Because of our interest and input of labor and so on into the Upper Pembina, they've been able to do a whole pile of work on their side in the Upper Pembina as well. So they were able to justify some of the work to their management that they do internally that's very much related to the project and the work that we're doing. We work very closely with the folks at Alberta Environment and Parks. And we've got some folks at Equality who come out and help us as well. And some of the slides that you'll see in a few minutes were prepared and analyzed by the folks at Equality.
That, and you don't know, but is that kind of a relationship similar to like other wildlife populations, or is it pretty easy the way to interact with them?
So the question is it a similar relationship for somebody else who might be working with maybe elk or deer or something like that, or other wildlife? That's a good question. I don't know too much about the relationships in other areas. I know that we do have really good working relationships with the folks, especially a number of different areas at environmental parks. I assume there's other organizations as well. I know that there's folks, for example, some of the work that they do down in the south, Trout Unlimited, the national office works with very closely with folks in Alberta Environmental Parks. And I know that there's other organizations, Cows and Fish, other organizations, some of the off-highway vehicle associations and so on that are building bridges and fixing up trails and so on. So yeah, we're not the only one that has these relationships, for sure. Trail cameras. So we installed 6 cameras this year, a couple on Dismal Creek, a couple on Rat Creek, 2 on the Pembina River. We set them up so that they take a picture every 15 minutes during daylight hours. So if you look at the number of, is it on there? Oh, that interesting statistic isn't on there. One photo every 15 minutes is about 50,000 pictures per camera. So somebody sits down, Jim O'Neill, thank you very much, and goes through thousands and thousands and thousands of pictures and looking to see if there's people that are angling, or he takes notes of what kind of wildlife are on there and so on. But of these thousands and thousands of pictures, we had 14 illegal angling events. So not very many. There's not a lot of angling activities where we had the cameras. 16 anglers, 5.5 hours. It's actually pretty insignificant. We do report this to the enforcement officers, and we'll tell them, okay, you know, there might be this one particular area, maybe it's a bridge crossing, maybe it's a little backcountry campsite or something like that. You know, every July long weekend, you know, for the last few years, we've seen a lot of activity. That'd be a good spot to go. And they do. They run out there and they visit some of those spots.
I don't think 16 non-compliances that we caught is really insignificant. With the amount of damage one fisherman can do on a daily.
One fisherman can do a lot of damage. You're right. I'm happy that it's not hundreds or thousands. I mean, 16, it seems like a manageable number. Yeah, but you're right. If Jim was doing this slide, he would probably have presented a slightly different way. From my perspective, 16 pictures with guys in it out of thousands and thousands and thousands is pretty small.
Anybody you recognize?
So one of the sites that Jim sent me an email, and he said, "Is this you?" Because there's a guy there standing on the side of the river with a fishing rod in his hand at one of the sites. And I said, "Yes, that was me." When we had a fisheries research license that allowed us to, while we were going out collecting the eDNA samples, so the idea was go out, collect the eDNA at that site, and then if you can throw a rod in while they're doing the filtering there. So there's a group of people that go, and some of them would collect the water. Somebody else would go in. The pump would take like sometimes it would take 45 minutes or an hour to get this liter of water through this filter. So there's time to kill. So I'll go there and fish. And the bonus was we could say, all right, we have very positive evidence. We caught an Arctic grayling or a grayling at that site. Let's make sure that the eDNA result is very high, or we get a positive hit at that site. And we were able to do that. So yeah.
When you talk about all this cooperation with provincial bodies,
Mhm.
there's a lot of private industry that's driving up and down those roads. Wouldn't it be a good idea to get some cooperation from them saying,
Mhm.
if somebody's fishing here, who do I talk to, or inform them that who to inform about people fishing illegally?
Yeah, it's a little tricky, but we could do that. We do. There's one site at Rat Creek where the Blaze Road crosses Rat Creek, and there's a very large watering station there. They withdraw water from Rat Creek, and we have talked to the truckers there. The trucks are in and out of that site all the time, like several times an hour. So there's one shot on the Pembina River. You can, it's a little hard to see on the little screen, but there's an angler here, and there's another one over here. That picture shows up. This is kind of interesting. We had a look here. You can see right along here, there's a very, very distinct coloration change here. And it was for a period of time, it was like a day that this one stretch just went absolutely mud brown. And there were some water withdrawals in that area as well. And we thought, oh, maybe it's the water withdrawals. Maybe they're doing something. We couldn't figure it out. We got the satellite pictures out and looked upstream, and there's a big bank. And we suspect happened on this particular one was that a big chunk of the bank had caved in and just colored up the water. So that was probably a natural event, that particular one. We didn't catch the guy doing the graffiti on the bridge there. Okay, that's kind of it for the cameras and the compliance and so on. We got a couple things. There's a picture of the camera. This is an air temperature monitor. So we've got a little temperature monitor inside that enclosure. So the ones that are in the air, we put them inside that so that the sun beating down on it doesn't over affect it. I just got these in the mail today. These are the data loggers, what they look like. So this particular one goes into the Big Array River. And what we'll do is put it inside of a metal sleeve like this and insulate it, and then attach aviation wire, that big thick wire, and basically wrap it around a tree, and then toss this steel thing into the river and come back. So we do that in the spring, come back in the fall and pick those up. And then they take this thing, put it into a little data port, and they read the information off here. So this little guy can hold easily a whole year's worth of information. Every 15 minutes, we take a temperature reading.
The tags that you've got in the fish, this is reading?
No, this is the temperature probe. So this is reading the temperature. I didn't bring any of the tags. The tags are little tiny things like this, and we haven't used those for years, actually.
No, but I thought that was for reading those microchips you're putting in the
Nope.
fish.
No, this that scanner is about this big. Yeah, no, this is just this is a fancy thermometer with a data chip in it, so that it writes the temperature every 15 minutes onto here. So 23 water sensors, 4 air sensors. We've been doing quite an extensive temperature monitoring program, much more extensive than a lot of areas in the province. Actually, there's a lot of temperature data. We've shared this with university groups that are interested in climate change. We shared it with a couple other groups. It's pretty interesting. Now, what we know is Dismal Creek is a lot colder than some of the other creeks that we look at. Bigoray, Patty Creek, some of the lower end sites. I'll show you in a second. They're at the point where there's probably not too many fish or any fish in those areas. Our water temperatures last year were quite a bit lower than the previous year, even though we observed some very low water temperatures in the fall. One of the creeks we went to, there was a beaver dam on it, and so our data logger was wet, but down below, just not too far below that, the stream bed was almost completely dry. So we know that there was low water temperature, low water volume. We're thinking it'd be low water temperatures, but they were actually not as low water levels, high temperatures didn't really pan out that way. There's a little bit more information there in a couple of slides. This slide is telling us that the fish have a preference for certain water temperatures. So for Arctic grayling, below 7.5 is a little bit too cold. They like it a little bit warmer than that. They're most happy between 7.5 and 17. We get 17 to 20, they're a little bit unhappy. At 20, they're distressed. They really don't like those high temperatures, 20 to 25. And above 25, a sustained 25-degree temperature is lethal to fish, to Arctic grayling. There's different fish have different temperature tolerances. This is the chart for the Arctic grayling. So on the left side of this chart, those are all the places that we had. Those are the sites that the Northern Lights group put the temperature probes in. There's also a whole bunch of other ones, but just for the handful, these are the Dismal Creek, Rat Creek, some Pembina River ones. These are the ones that we're most interested in. June, all green, nice and cool. July, we're getting a little bit of yellow, but not too bad. The monthly average on some of the lower sites in the Pembina, we got into the red range. So the fish are distressed. They're bugging out of there. They're lethargic. They're not happy at all. And into September, everything was green again. The maximum recorded temperatures are down the side here. So some of these spots we got in a really warm spell, got temperatures up to 26 degrees in the water. That's into that lethal range. This next slide is the previous year. Okay, so this is 2022. The next slide is 2021. So just for a comparison, the general observation is 22 was cooler than 21. There's 21. So we got temperatures up into 30 over here. And if you compare the first couple of columns, remember we had that heat dome from in 21? Heat dome, we got high temperatures starting in June, and we got a whole bunch of lethals in July. Just going back a slide and then forward again. So last year was actually a lot cooler. I'm going to put these slides up on the website if anybody wants to look at more detailed information. I'm not going to talk about it except for one number down here at the bottom. This is of all those sites, the number of days that were above 17 degrees. So 17 is that, okay, I'm comfortable. Above it is I'm starting to get uncomfortable. 486 total days versus 642 the year before. Of the really hot days, the 20-degree threshold, 270 last year compared to 550 the year before. Quite a bit cooler last year. And that just charts it out. The 2021 was the hot year. 20 was a cold year, and last year was right in between. So they bounce around a little bit, but those are sort of the temperature ranges for 3 years.
So does the temperature pretty much follow the amount of rainfall they get to?
That would be a factor, but we've never tried to correlate it to rainfall.
The average rainfall for the year for that area or whatever.
Yeah, that would be a good thought.
Temperature of the water will also increase as the river shallows
That's right.
as well.
That's right.
So like it goes through these. That's what
Well, it's just the opposite of what happened.
At the end of the year, we thought we had low water levels. I thought we would have high temperatures, but it didn't really pan out that way. So this slide is very busy, and this is for looking at later, but I'll give you the basic flavor of it. I'll pick this one over here. This is one of the sites on the Pembina River. This is the last 10 years or so worth of data. And this is the average number of green days, yellow days, red days. So although last year was cooler than the year before, it still had a lot of red days in it compared to the previous number of years. So last year was warm, but not as hot as the year before. This is the Upper Pembina, the upper part of the Upper Pembina, above the Pembina Forks. So some of the little streams, it's all green up there. And that's just a zoom in of the lower section. I'll leave these. If anybody's interested, we can go look at them online.
Any DNA testing at the upper level?
Yes, we'll get to the DNA stuff in a few minutes. Yeah. Just a little bit about the aerial photography. This is a busy slide, but this is the Blaze Road. So this is one of the main roads. This is the one I told you earlier about, said we had lots of water withdrawals here. This is one of our main sites. Actually, Michael and I fished there 8 years ago or so. We had a really good day on Rat Creek. We caught probably 2 or 3 dozen grayling on one particular day. Yeah. So this has been a good site. And when we're fishing in here, we generally fish this area right here. We got our maps out and said, what happens if we follow this road up here and zigzag and come up here? What's the access like and what do we look like? So we flew the drone. So that's the drone flight there, one of the green ones. And we drove up here. We flew around this other spot. And we actually found some pretty nice habitat. We'll try this and see if it works. My browser is up to date. That's good. When I did this at home, it showed me a YouTube video. Let me try this again. My browser's up to date. Yay. There it is. The internet is through that group of people and above. So
Where's the light switch? Is it like cut the lights to the front of the stuff?
light switch is back in the corner there. Yeah, so it's coming in low res, but we can post the link here to give you an idea of what we can see with the drone. And that is really low res. So we're just not getting a good internet signal down here. So let me get out of here. The idea is we found some good habitat. It looks like there's some pretty good access along there. So there's some little cut lines that we can get in on. And we want to spend some more people out to those particular areas next year. eDNA. So this is the new and interesting part of the project this year. eDNA stands for environmental DNA. So everybody's familiar with what DNA is. It's if you took a skin scraping or something like that, my DNA is unique from yours, is distinguished, is different than everybody else's. So that it's the molecular level of pardon me?
Genetic markers?
Genetic markers, sure. But basically your genetic buildup. If you get all the way down to the cell and the genes and everything that puts things together, they're all distinct. So environmental DNA is the DNA that can be collected out of the environment. So as a fish swims in a stream and poops and blows his nose and has mucus come off the side, in spawning time, it's the gametes. If it's dead, then it's decomposition. These are all things that kind of float around in the river, and they could be minuscule little tiny amounts. In fact, there's a quote coming up in a few minutes that it would only take a few cells to show up a positive hit on eDNA. So there's all this stuff that's floating around in the water, and what they can do is gather it up, take a water sample, filter it through a very, very tiny filter, send that filter off to a lab, preserve it, send it off to a lab, and then they can basically replicate or intensify the DNA, amplify is the right word, amplify the DNA, look at it, and then they can say, okay, we know that we're looking for this particular DNA strand or this DNA marker or whatever it is. And they can say, this is what an Arctic grayling looks like, and you had some of it in that part of in the water. So it means that you can go out and take a water sample from a bunch of different places without having to go out with an electrofisher, without having to go out and sample the fish or catch them some other way. You basically take a sample and say, are there any in here? There was a couple years ago, there was a stream up near, where was it? Up by Slave Lake. And the researchers were just kind of getting their feet wet with this eDNA stuff. They went out and recorded a bunch of locations up in the Slave Lake area. And one of the biologists on one of the calls I was on said, you know, we got a weak hit on this particular stream, and we've never had any evidence of fish in that creek. So, you know, they're a little skeptical. But so I happened to be camping up in the area. So I went out there with my rod and I found this little stream that was about the wide as this table here. And I thought, there's no grayling in here. I fished it for about 20 minutes and caught an Arctic grayling in this area that I never, ever would have tried to fish if I didn't have this little tidbit of information that says, oh, there was eDNA that said there's a grayling in there. So I went looking for it. I measured it, I took pictures, I recorded. The biologists were so happy that they now had something they could put into their database to say, yes, there actually are Arctic grayling in that little stream. It was kind of fun. All right, that is a side story.
Shelley said that there was one fish in those lakes they killed.
Yeah.
eDNA would show up that they didn't get enough.
That's right. That's right. So Shelley Humphreys was talking to us a couple weeks ago about Hidden Lake, and she said that if there was a fish in that lake, their eDNA samples would have picked it up. That's what Bill was saying. So it's non-invasive. You don't have to go and kill fish. You don't have to go and electrocute them or electrofish them. Electrocute was the wrong word to use there. You don't have to electrofish them. It's pretty easy to go out there. It's way less work than all these other things. But that's how it's useful. So what do? Collect the water samples. We put it through the little filter. We preserve it, and then there's a sterilization routine between each spot. So we go and bleach everything down and make sure that there's no contaminants before we move on to the next site. The lady here on the left is she was at the University of Alberta, one of the leading eDNA people. These two guys are the provincial biologists from Edson. So that's Mike Blackburn and Ryan Cox. And they're getting trained on how to collect the eDNA. So basically, grab the water sample from the stream here. And basically, you look for a spot that's fishy looking, good fish holding habitat. You want to try and catch something where the fish are holding or have been or holding or have been, basically. The water goes into the, you can't really see it very well here, but there's a tube here that is connected to a little funnel. Water goes into the funnel, it all gets sucked down, little filter goes to the lab. That's what we did. So some of our volunteers went out and did this work and collected with the other folks. Then you get into the a bunch of lab work. So it's purified, it's amplified. There's a bunch of fancy technical terms, qPCR. There's some machines that all this stuff goes into, and I'm trying to keep this simple because that's actually about the limit of my understanding of it anyway. But they have a whole bunch of machines and lab work that goes on to filter it and look at it and say, all right, we got a hit. And basically, for one of these samples, there needs to be 8 copies. So they, when they're replicating it, making it bigger, they could find this all from one cell. So where Shelley could take a fish in a lake and say, oh yeah, there's that, some of those fish are in that lake. They could go and say, I've got one cell here. That's enough for identifying one cell off of a fish that happened to be caught up in this filter would be enough to say, oh yeah, we got them here. Very cool stuff. So here's a few pictures. The top left is a fridge full of our filters. There's a qPCR machine and the machine that is used to help replicate. That's one of the lab techs that was working with us at the University of Alberta. So what did we find out? We went to 36 sites and sampled, and 24 of them came back as positive for Arctic grayling. Now, what was really interesting is these black ones up here, up in the upper end, that's negative. So in that cold, clear water, it must have been too cold, or we were there at the wrong time of year. It wasn't spawning time. There's a few factors there, but basically, those high mountain areas. This is a number of the smaller streams, smaller tributaries to Dismal Creek and to the Upper Pembina River. No grayling were detected there. Some of the other guys, this was an interesting one here. This is kind of down on the lower end. Got a signal down below where we were expecting to find it. So could have been a dead fish, could have been a few other things, but interesting. Also interesting was one of these creeks over here that we had kind of previously written off, Paddy Creek. It had some fish in it. So they might have been just little guys, young of the year, but there are still some Arctic grayling in Paddy Creek. So no surprises in this middle section. This is where we've been catching them. We know that they were in there. Kind of surprising that there weren't some up here in the top end. So what does it mean? What does it mean to our project? What are we going to do next? We actually had planned to go and do some angling up in Lovett River, Crooked Creek, Hansard Creek, a few others up there. But based on this eDNA evidence, we're going to say, you know what? We'd be better off to go and focus on Rat Creek and a couple of those other ones. We'll put our energy in there for the next year or two instead of worrying about where these fish aren't way up in the upper reaches.
Did they test for any other type of thing?
No. So the assays that they used were very specific for Arctic grayling. We said use your testing and find out if there are Arctic grayling there. They're using eDNA as part of native trout recovery to look for rainbow trout, bull trout, and westlow cutthroat. Those are some other projects that we're not involved in, but there are people that are using that technology. The researcher asked us if we could take our samples and submit them to, there's another research group that's working that is basically cataloging all these different things. So they want to be able to take a sample and say, all right, I've got this water sample. Can you test it for rainbow trout, bull trout, whitefish, whatever? They're working on that, but that they're not quite ready to do that just yet. They've asked us to contribute our samples so that they can build up that capability, but it's not there just yet. Oh yeah, there are brook trout up in the upper reaches. Yeah, for sure. There's lots of brook trout. They have caught the odd bull trout up in some of the upper parts of the Pembina there, but there's lots of brook trout. And there are some, but not lots of whitefish as well. I don't recall. I wouldn't be. There's there's Athabasca rainbow for sure in the next watershed over, up not far from where we've been fishing, but on the other side, I know there's Athabasca rainbows up there. Okay, 2023, what are we going to do? Going to do the temperature logger routine again. We have, go to the next slide. So this work has all been approved by ACA, so we're going to go ahead and do the data loggers. We have a new drone with some newer technology in it that will let us travel a little bit further. And so we'll be revisiting many of these sites again, and a few new ones as well. We're going to, there's a gap in some of the data from Rat Creek. So we have lots of samples from lots of samples from Dismal Creek. We don't have as many physical fin clips and DNA samples to carry out some other work from Rat Creek. So, and it's specifically post-closure. So we had lots of Rat Creek fish from before the closure, but not many after. So we want to go out and capture some grayling, take the fin clips, and finish off a little bit of DNA work on the Rat Creek side of things. We'll do the non-compliance cameras again, and the volunteer angling to add that another data point into that angling closure study. So we'll be going out through the Upper Pembina. That's the plan. There's an election. There's lots of things happening. There's people being moved around. The biologists don't know yet what their work plan is, but we're certainly hoping that we'll be able to do that work with them again as well. So, angling opportunities, volunteer opportunities. The first job is the Rat Creek work. In this particular study, they will give us a research license. We'll have to closely monitor it so that we know who's going out at which time, because we have to tell the enforcement officers we're going to be on this stretch of the stream at these times and so on. But basically, they will give us a license that lets us go out as a group or as individuals and angle on these closed streams. So if anybody wants to get out and do some angling on an area that rarely gets angled, we do have some time in June, July, and August to go out and catch some fish. All we have to do is catch the fish, measure it, take a few like a temperature reading at the beginning, and a fin clip that goes into an envelope. Just mark down a little bit of data, but that's basically what they're looking for. And we'll end up collecting these DNAs, these fin clips that we can use for DNA analysis.
Do we need to do GPS readings?
Yes-ish. If you know, if we're, well, for example, if I know Dennis is going out, there's no point in even asking for a GPS reading, because it's probably, I know you have one.
I just put 2 batteries in it too.
Oh, there we go.
If we go out and say, go to this site, angle between here and here, that's close enough. Yeah, so it's not, doesn't have to be super technical. We just need to know which stretch, and that's close enough for the work that we're doing. So we can go out as individuals, we can go out as pairs, we can go out as a blitz. Haven't quite figured it out yet. There will be emails going out to the effect. We need to wait for some water temperatures and stream conditions, and work with the biologists to make sure that we know when and where. But that's coming.
And when did we know why make sure that we go in pairs? No, I mean,
Okay, so sorry, I said individuals. We wouldn't send an individual out. We will not send an individual out on this exercise. We can go out as pairs. Yeah. No. We'll send at least pairs out. We've done the blitz before where we'll go out with, a few groups of people and say, all right, you three go here, you three go here, and we hit it all on the same day. We can do that as well. So that those plans are in the works. Jimmy.
Never go out there fishing.
Right.
Michael or something.
That's right.
Just in case.
Yeah. No, all of the work that we will do will be at least in pairs.
But you want to mention, you have to be a drug limited member to do this. Don't you?
Yes.
And then they should sign up on the Grayling email list.
Yeah, we're going to send this out on our newsletter list, so it'll go out fairly wide, and we'll make sure that we catch all the people that have been involved before. It's volunteer time, but we do have we have some gas cards that cover your fuel expenses and a little bit. So we have a way to remunerate the people that are going out. The second one is very similar. This will be more specific days. We'll have there's 2 biologists that we'll work with. So 2 guys will go with Mike, 2 guys will go with Ryan, and that opportunity will be beginning of August, mid-August, somewhere in there. Same kind of idea.
Have you carry his vest?
Say that again?
Don't that might have you carry his vest?
Like Blackburn?
Yeah.
So yeah, some of the guys collect petrified wood, and I've seen it go into the vest. So if he says, please carry my vest, yeah.
75 pounds, he says his vest carry.
Any questions? If you have a question on the Zoom call, just unmute and here, let me do this. Stop the sharing. See if there's anybody left on the call here. Any questions from anywhere on the Arctic Grayling project? Everybody wants to go.
There been any follow-up on the Freeman and the? I was gonna ask you that.
Okay, that's a good question. That's a little mini presentation that I've got after this one here. So I'm going to stop the recorder here. If I can find the button.